In this particular video, I want us to look at topic 3 of A-level physics. There is 9702 A-level physics. That is year 13 of CIE. We have had a discussion on the first topic. We looked at the kind of question you'll be asked in circular motion. The topics we discussed this, and if you have not watched the tutorial regarding this particular video, consider checking out so that you can be able to check through and get to understand what was the main areas to be covered as far as circular motion is concerned. So after looking at circular motion, we also went ahead to discuss about gravitational field strength, and we defined the term gravitational field strength, so whereby we said is a force per unit mass. We worked about the forces holding different objects together, and that is Newton's law of gravitational fields, which is force is the force between two objects which are a given distance r apart is directly proportional to the product of their masses and inversely proportional to the square of the distance between the centers of those two objects. So we discussed that, and we went ahead to show Kepler's third law, which can be also be used to calculate the orbital radius of a satellite. Then we talked about geostationary orbits and geostationary satellites, whereby you have to understand the characteristics of geostationary orbits. And number one, they have the same period as that of the rotational of the planet or the Earth. It orbits from west to east, and also it orbits directly above the equator. We went ahead to look at fields of point masses, gravitational fields. So those are the main areas that you really need to understand. Escape velocity. And if you want to access these notes, you can be able to check in our Patreon page, where you can be able to download the PDF of these notes so that you can be able to go through as you prepare for your A-level exams. Topic 3, thermal energy and thermal equilibrium is the area of focus, and I need to mention in this particular section here, the most important part that you really need to understand is what do we mean by thermal equilibrium. And you need to understand that thermal equilibrium is of two objects. If two objects are in thermal equilibrium, what does that really mean? It means that these two objects, they have the same temperature. They are at the same temperature. So if the two objects are at the same temperature, it means that there's not going to be any net heat flow between one object to another. So now when you're going to have your exam, you are going to get that particular question being asked in multiple times. You'll find them asking you, what do we mean by thermal equilibrium? So let me just check if we've ever had a question like that in the previous exams. You can see here, they'll ask you, state what's meant by two objects being in thermal equilibrium. In that case, you are going to say two objects are said to be in thermal equilibrium if there is no net heat flow between the two objects and the two objects are at the same temperature. So meaning that there will be no any heat flowing from one object to another. So that is exactly why we are highlighting that in our notes here. And you need to understand also temperature scales. We have a Kelvin scale, which is measured in kelvins, and we have also the Celsius scale, which is measured in degree Celsius. And let me say, if you are new to Proflan YouTube channel, consider subscribing so that anytime we are going to do further tutorials, you'll be notified. And if you have not joined our Patreon page, kindly just check the link in the description so that you can be able to go straight into our Patreon page. You sign up there, you join there, you support Proflan, and then at the same time you will be benefiting from our materials and our resources that we shall be uploading there. So as far as this topic is concerned, remember to convert. You know how to convert Kelvin to degrees Celsius and from degrees Celsius to Kelvin, and you can see the formula here. You need to understand what we mean by absolute temperature, and that is going to be the minimum temperature a given a gas will have theoretically zero kinetic energy. Yeah, so that is it. Then another term that you're going to really make sure that you know how to define is specific heat capacity, latent heat of fusion, latent heat of vaporization. You need to understand that, so that in time they are going to ask you a question, you'll be in a position to answer that. So look at this here. We are having specific heat capacity and latent heat of vaporization. What's heat capacity? Heat capacity is the amount of thermal heat capacity of a body, is the amount of heat energy needed to raise the temperature of a substance by 1 degree Celsius or by 1 Kelvin. The amount of thermal energy required to raise the temperature of a substance, that is what we call thermal capacity. Then when we are talking about specific heat capacity, we are very specific with the amount of mass involved of the substance. So which means we are going to be talking about 1 kg of a substance. The amount of heat required to raise the temperature of 1 kg of a substance by 1 degree Celsius or by 1 Kelvin is what we call the specific heat capacity. And in that way, you must be at A levels, at A level physics, you must be able to be in a position of calculating the specific heat capacity. You can be able to describe an experiment on that, right? So which means that if you set up the circuit as shown here, yeah, I just need something to point. So you see we are having a circuit that is connected to an electrical heater. So meaning the electrical heater will be supplying the heat, and that heat will be absorbed by the substance that whose specific heat capacity that we need to find. So meaning you can be able to calculate amount of energy electrical energy supplied by the heater is IVT. Yeah, so we know quantity of heat is MC change in theta, mass of the substance and specific capacity times temperature change. But the amount of heat energy that is supplied to this object is by the electrical heater, which is going to be IVT, current times voltage times time. That's why we are having this quantity here, so that you can be able to measure current, voltage and time. Then also you need to have a stopwatch. You need to have a stopwatch which will enable you to measure the time, the duration, right? Then if you take the I current times voltage times time divided by the mass of the substance that is being determined times the temperature change, where you are using the thermometer here to measure the temperature, then we are going to get the specific heat capacity. And this is basically the experiment that you are going to use in order to determine the specific heat capacity. So apart from that, we also need to understand the concept that of latent heat of fusion, because when substances are melting and when substances are evaporating, there is latent heat, and this latent heat is the heat that is used to melt a substance at constant temperature or change it to vapor, a liquid to vapor at constant temperature. So latent heat means hidden heat. This heat will not be able to change the temperature of the liquid, but it will be used to break the intermolecular forces that holding the particles together. So from year 7, you had learned about solids having particles closely packed, liquid particles move slide over each other. For gases, the particles are very much spaced, very far away from each other. So why does that happen? Is because the particles, they don't have intermolecular forces. Yeah, but for liquid they're a bit close. For solid, they are fixed and they vibrate in their fixed position. So in that way, you need to understand how to calculate amount of thermal energy required to melt a substance, and that is going to be quantity of heat is equals to mass times latent heat of fusion. Specific latent heat of fusion is the amount of heat required to melt a solid at constant temperature, at its melting point. So you need to understand how to define specific latent heat of fusion, specific heat of vaporization, and specific heat capacity. Let me just give you an overview. What's meant by what? What's meant by specific latent heat? What's meant by specific latent heat? Here we're going to say this is the amount of thermal energy required to change state of a unit mass of a substance at constant temperature. Yeah. You will also be required to define specific heat capacity. We're going to say the amount of thermal energy required to change a unit mass of a substance by what amount? By 1 degree Celsius in that case. So all this you will be able to get them in our Patreon page so that you can be able to download them. We have already said the concept of thermal equilibrium, so we shall look into that. So the amount of heat energy required to vaporize a liquid is M times the latent heat of vaporization. So meaning the amount of heat required to vaporize 1 kg of a substance at constant temperature is called latent heat of vaporization. So you also need to understand that heat loss is equals to the heat gain in this particular topic, so that whenever you are going to be asked questions where you are supposed to work out the specific heat capacity or mass of substances, you will be in a position to do that particular calculations. So for instance, here you are told that ice cube of mass 37 grams at a temperature of 0 degrees Celsius is placed in a beaker containing water of mass 208, and this water is at 64 degrees Celsius. So which means that there is hot water and then ice is going to be dropped into hot water. So which means that this ice is going to absorb the heat and then it will melt. Once all the ice has melted into water, it will become cold water at 0 degrees Celsius. Then the temperature of water will rise from 0 to 10.3 degrees Celsius. So in order to work out the specific heat of fusion, we need to remember that heat that is required to melt the ice is mass of the ice times the latent heat of fusion, whereby we only know the mass, which is 37 LV. So we are going to say 37 times L, which is the latent heat of fusion of the ice. Then the amount of heat that is used to raise the melted ice will be mass times specific capacity times the temperature change. Now the temperature change here is going to be 10.3 because the temperature of water is rising, of this cold water, of this ice that melted became cold water at 0 degrees Celsius. Then that water is going to rise, temperature is going to raise up to 10.3. So we are going to say the mass of ice was 37, so the water that will melt there will be 37 also times the specific capacity times the temperature change. So the ice that was melted will need 1593 joules to raise its temperature up to 10.3. So but the hot water that was 208 will lose heat. So amount of heat lost by hot water will be the mass of hot water, which was 208 times specific capacity of water times temperature change, because temperature was 26.4 and the temperature decreased to 10.3, so the temperature change there will be 16.1. So heat lost by water is going to be this value, and then we are going to say heat gained will be this heat that we have here plus this heat of the water here. Then we shall say is equals to this. We make L specific latent heat of fusion, which is LV subject, and then we are going to get the value as shown here. Yeah, so basically that's what you will do. Also we did look at we need also to look at other questions that are like this here, so you need to be in a position to answer these questions. Now the next concept that you're gonna need to understand is that latent heat of vaporization is greater than the latent heat of fusion, because latent heat of fusion is the amount of heat required to separate a liquid to gas. So meaning the intermolecular spaces for gases is wider. So the amount of heat you need to push the molecules much far apart is basically supposed to be more. Yeah, so that is why we're going to say the comparison between latent heat of vaporization and latent heat of fusion is that latent heat of fusion vaporization is more compared to the latent heat of vaporization. At this level, you need also to understand the concept of the first law of thermodynamics, which is the internal energy is equal to the amount of thermal energy supplied minus the amount of work done by that gas or by that substance. Yeah, so a very interesting concept. Next area you shall look at is ideal gases. Under ideal gases, you must be able to know how to define an ideal gas. An ideal gas is a type of gas that obeys this particular equation: P V is proportional to T, and it obeys this under all conditions of pressure and temperature. Boyle's law is a concept also to look at, and the Boyle's law is trying to relate how pressure and volume vary. We are going to say this is going to be pressure and volume, so I have to change this: pressure and volume. We are going to say pressure is inversely proportional to volume, and if you draw you plot a graph of pressure against volume, is going to be a curve like that, whereby this upper curve here is representing a graph where temperature is more. You are going to have a curve like that, but if temperature is less, you are going to have a curve that is just below like that. But if we are talking about a graph of pressure against 1 over V, is going to be a straight line graph that is going to pass through the origin. We shall also have Charles' law, dealt on at A-level physics. And then when you combine Charles' law and the Boyle's law, you are going to have the ideal gas equation, which is PV is equals to nRT, whereby N is the number of moles of an ideal gas, and then R is the universal molar constant, which is a constant that you'll be having in your formulas and constants, and then you have the thermodynamic temperature at that particular point. So these are the formulas that you really need to understand as far as thermodynamics A-level physics is concerned. Here we've just done an example which will enable you to understand how you can be able to make use of this formula. But remember that K here is a constant, which is Boltzmann constant, and then we have N, which represent the number of molecules of the gas, and then temperature is T, is representing the temperature. As we are approaching the end of the topic, you must be able to derive this pressure of an ideal gas formula, which we are going to do here. We shall be able to work this in our next session. So if you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to work on the next series of this particular video, you'll be notified. So if you are new, consider checking also in our Patreon page so that you can be able to access the rest of the notes in this particular part, so that you can be able to continue learning with us. So I wish you the best of luck, guys. All the best in your exam. See you in the next tutorial.